Hello, I'm Tom Sugar. I'm a professor in robotics at ASU Polytechnic campus. Today I'm going to talk about assistive robots, robots that help people if you've had an injury, if you've had a stroke, or systems that can just help you do a task easier. Human-robot interaction and robot-aided rehabilitation are focus areas in ASU Associate Professor Hyunlai Lee's Neurorobotics Lab. Lee's work often uses human-robot interaction to improve walking for stroke victims, incorporating the dynamics between the foot on the ground with the action of the other leg swinging into the next step. These posture dynamics are part of a recent pilot study focused on improving gait stability for children with cerebral palsy. Working with clinicians from the Mayo Clinic and Midwestern University, Lee's team was able to register improvements for posture, balance, and walking function at the end of a 6-week study. Another distinctive project in Lee's lab is a robot-aided exoskeleton designed to emulate the distinct neuromuscular properties of the human shoulder. While it may look like a prop from the movie Edward Scissorhands, the device has applications for patients recovering from stroke, and its design is serving as a prototype for hip, wrist, and ankle interactions. Someday your dentist may have a robot assisting who passes instruments, prepares your filling material, and hands you a tissue to wipe your mouth, all from behind the dentist. The goggles your dentist is wearing, in addition to having directed lights or enhanced vision, may also allow seeing what the robot is doing in the background via virtual, non-interruptive shadows. This kind of robot-human teaming, which allows collaboration across distances without direct vision, is being developed by Andrew Boding in Professor Yu Tony Jung's Cooperative Robotic Systems Lab. Such capability could allow a warehouse organizer, while focusing on rearranging products, to only need to see the shadows of robotic helpers that are assisting from behind for occasional but critical human intervention. Without direct vision, these virtual shadows provide a sixth sense for proximal human-robot interaction. According to Jung, the applications will be valuable across many platforms, including manufacturing, warehousing, agricultural, and medicine. A new robotic technology for interventional radiology, or IR, is being developed by researchers in Dr. Harmeed Marvi's lab at ASU. IR utilizes catheters and needles to perform a variety of surgical procedures, such as targeted drug delivery, blocking blood flow to cancer cells, or implanting a neurostimulator for a Parkinson's patient. Currently, a needle must be rigid to be pushed to its target through the tissue. Despite radiological guidance, a hard device can be met with bone obstructions or can perforate an artery, requiring a halt to the procedure. The new technology circumvents these issues through magnetic pulling of a soft catheter needle rather than mechanical pushing of a stiff one. It also eliminates radiation exposure by using a non-visual tracking system. Guidance and tracking are accomplished externally by one or multiple robotic arms carrying an array of magnets. Do you need a hand at work? The Aerial Porter Exoskeleton, or APEX, can help you push, lift, and carry your workload. Originally designed by my team to help U.S. Air Force aerial porters load and lift pallets onto cargo planes, the device has several applications in the general workforce. The device has both passive elements like hip stabilizers and active elements to provide robotic assistance for lifting and pushing. Trials have confirmed that APEX can assist a team of 4 people in loading a pallet with up to 10,000 pounds of equipment and then push it onto an airplane. In addition to lightening the workload of warehouse, manufacturing, and postal workers worldwide, the device can also reduce workforce injuries. The project was initially funded by the Department of Defense to mitigate the high incidence of musculoskeletal injuries costing more than $31 million in disability benefits for retired Air Force aerial porters alone.